Okay, great, thanks. So, unlocking assets management with DJI Dock 2 in the energy sector. Starting this topic, I prefer to talk about DJI story. As we both know that we are industry leading in drone technology company, drone manufacturer and the well-known company in the drone sector. Our company actually founded in 2006. At that time, we are still a small team. And later in 2017, we start to establish DJI Enterprise Division, which is providing the drone for professional drone users for industry use. And for the past 6, 7 years, we've been pushing hard to the limit of the drone technology. And in the past 2 years, we start to give the market the new generation of drone technology, DJI docking solution, or as known as the drone box. In 2022, we introduced the DJI Dock 1. It's our first generation drone box solution to the market. And in the March of this year, we introduced the DJI Dock 2 as advanced generation of docking station. DJI Dock 2 is a automated assets inspection tool. We generate all of our best drone technology into one product, including the precise landing, also the mission planning, also the automated mission, also the professional surveying, and mapping in the software. There's a lot of advantage. I will pick several of them to share with my audience. First is very small. It's also as known as mini dock. It's light and lighting weight. It's only 34 kilograms and takes 0.34 meter in square. Small and light, easy to deploy and maintain. And second, it's very reliable. The drone itself has IP54 rating to prove the water and the dust. And the docking station have IP55 IP rating for it. So the Dock 2 solution can stably work even in the harsh environments. And third, about the efficiency. One single flight, the Dock 2 drone can reach 50 minutes flights in one single. And we can take off within 45 seconds, which is really good for emergency response. Speaking of the accuracy, we integrated the professional surveying camera into Mavic 3 dock version drone, M3D, with mechanical shutter and 4.3 CMOS plus 0.7 meter interval shot time to find a good balancing in accuracy and the efficiency of mapping. We know that software is the soul of the solution, of the hardware, I would say. And the FlyHub 2 as a software compatible with DJI Dock 2, we are adding more and more function on the FlyHub 2, including the cloud reconstruction, 2D map comparisons, and so on. Later, Sam will, in his session, he will give a detailed introduction of FlyHub 2, the new use case. And the last point about the pricing. Compared with first generation, it's actually lower cost of deployment and maintenance. Also, the hardware price is becoming more amazing. So we have the product. Then we start to search for some partner to give us some feedback how we can improve it. Is it a really good product for the market? And that's at that time it's our best choice. We start our project from November, and in the last 5 months, we've been go through the introduction preparation of the project, including the presentation, the training, and later the installation, deployment, and later to the first thermal power plant site testing, and second the solar power plant testing, and later generate a report and create use case video to share with all the markets. It's a huge project, and during the project, it's the Samuel and his team is showing a lot of professionality and cooperation to us. Yeah. So what results we made? During the past 5 months, we created like more than 100 missions and so many flight hours. From DJI perspective, they are one of the most valuable customers for us. They test all of our solutions' major functions and also provide us so many interesting product improvement advice. They are helping us to improve the product and help us to make the industry grow better. This is truly valuable for DJI, also to the industry, I believe. Okay, and after that, the next question is how we're gonna distribute all of those results. Actually, today's webinar is part of the distribution of our results. We want to form one DJI webinar to dive detail into the assets inspection, also to create a method for our audience to have a communication way with Samuel and his team. And besides that, we also posted one DJI blog 1 month ago about construction management. Besides that, Samuel from Endesa, he created many showcase videos to deep dive to introduce general step-by-step how to deploy Dock, how to use it in thermal plant, in construction, in demolition, and use case in the solar plant, which is very interesting. Later, Samuel will dive deeper about all of the contents. Yeah, as I just quick introduced, today we have Paco Molina. He's the head of industry risk and cross-technology improvement. And he's here to give us the general idea of who is Endesa, what is our project, and what is his opinion of the product. And later we will have Samuel, who is responsible for drone operator in Endesa Army department, to dive deeper about all the use case and all the real world operations. In my last words of my speech, I want to one more time express my sincere gratitude to my dear customers. It's really good project for me. Also, we receive a lot and learn a lot during the cooperation with you. Also, I believe in the future, not away from now, we're gonna start more and more projects, and we're gonna make it even better. So that's it from my side. And Paco, are you ready to take the mic?
Yes.
Yeah,
yes.
Please.
Please. Let me
Samuel,
present
can you?
Irving. Yeah.
Yeah.
Yeah, sure.
Well, very good morning to all of you. My name is Paco Molina. I don't know if are you?
Yeah.
Samuel,
I'm sorry to
ready?
present. Yeah. I'm
okay.
Here.
Okay, perfect. So my name is Paco Molina. Sorry, because my name of the bottom of the screen, I think there is a mistake. I'm not Samuel, as you can see. I'm Paco Molina. Samuel is my colleague. Well, Paco Molina, thank you for joining this meeting, and thank you to DJI for inviting me. Very briefly, just some note about myself. I have worked in the Enel Group for the last 14 years. Initially, I worked in the engineering department, focused on hydroelectric and pumping project. Then I moved to my current department, where I have been working for the last 8 years. During the next 30 minutes, we are going to tell, as Irving told you before, we are going to tell you about our collaboration with DJI Enterprise Group, and in particular, we will share our experience with the specific product of DJI Dock 2. Before starting, I would like to thank you, DJI Enterprise, for your collaboration and dedication to this joint venture, and specifically to the person who just introduced me, Irving. Thank you so much for your support. This project between Endesa, a leader in the energy sector, and DJI, a leader in drone manufacturing, a developing company, is a proof of, in my opinion, of our commitment of our commitment to excellence in the pursuit of a sustainable energy future, so demand nowadays. In my opinion, this collaboration is a clear example of how two giants in their respective field can join together to tackle a complex challenge. Well, this is the agenda for today. A brief introduction for Enel Group, then the drone operator in our company, and then the specific topic of the DJI Dock 2 project. So go ahead, Samuel, please. Yes. I begin with a brief description of Enel Group. 47 countries, more than 65,000 employed people. There are three main lines of business: global infrastructure and network, global customer, and the line where I belong is a global power generation, whose mission is the generation of electricity, typically renewable electricity. So keep going. Well, this is the main figure of this line: global power generation, 86 gigawatt installed capacity, more than 60% of renewable energy. This is a very important point, and also I can say that this number is increasing regarding the renewable energy. All these gigawatt are distributed in more than 1,200 power plant. Now this number in Spain, we can see the Enel Group in Spain. These are the figure, the number. 18 gigawatt and more than 3,070 power plant. The technology deep dive is there. We in Spain we have. You can go back, someone, please.
Yeah, sorry, sir.
Can you go back? Yeah, we have a technology: wind, solar, hydro, thermal, but no storage. Well, just a pilot and geothermal. So go somewhere, please. But we continue to go down the level within the generation in Spain, the Enel Group. There is the OMI department. There is the Operation and Maintenance Improvement Department, and below it is the department where we work, the IRT department, Industrial Risk and Cross Technology Improvement. These are the main activities we manage: the industrial risk, communication, drones activities, digital twin, smart glasses, metaverse. Metaverse is a very new activity. And this is the team. We are 5 people: Javier, Victor, Rocío, and Samuel. 2 of them pilot. Javier is Samuel. And hopefully the woman in the team, Rocío, will also join as pilot at the end of the year. A very important point that I consider in my department is that we work with all technologies: solar, wind, hydro, and thermal, but also we work in the whole value chain. I mean, not only and especially within O&M power plant or power plant in operation, but also with innovation, business development, health and safety, engineering and construction, and even for dismantling coal power plant, as we can see later. Okay, this is I'm going to give a summary about the drone operator of our department. Well, not department, of our company generation in Spain, called Endesa Generación. some figure. This is the most important, the biggest one in Spain. We have 39 drones, most of them from DJI colleagues. We have more than 50 pilots, and we perform more than 300 operations per year. Maybe for another country like China, these are not so big number, but for Spain, I confirm you that this is the most important one. Below you can see AESA is the organism that manage the space, the airspace in Spain. Is below EASA, is the one for Europe perimeter. Well, to control and to coordinate all this operation, we created several months ago a unit inside the department called Grupo Tecnológico de Drones, with Samuel and Javier in charge, who are by far the most, both of them are by far the most experienced pilots, not only in Spain, but also in the entire Enel Group. They are responsible for the operation and maintenance of all the drones fleet in Spain. Go, Samuel, please. Yes, this is, well, my last topic today, and of course the most important one in terms of how I want to explain briefly our agreement with DJI Enterprise Company, and in particular the Dock 2 project. You can go, Samuel.
Yep.
Yeah, well, the Dock project. I have to say that this is the topic, but the first collaboration, but after several months with Irving and all the team, the DJI team, we have both found other possible collaboration, which we hope to start to carry out in the next month or even years. So yes, very briefly, this is the last slide. And very briefly, what have been the deadline in which we have moved for this project? In July last year, initial contact, Endesa, Enel Group with DJI. Last November, the first unit and the installation of the first unit of Dock 2 in the final phase of a commissioning of a decommissioning or dismantling power plant called Teruel until February. Then we installed this same unit. This power plant, coal power plant, was very close to the solar power plant, existing solar power plant. So we moved it just like 1 kilometer. We installed the dock in a solar power plant operating. And we hope to keep this in this file until several years. Today, July, we are going to include another power plant very close to that one, a solar power plant, the construction of Mudéjar solar power plant. So this is very important. With a single dock, we are providing service to 2 power plants, one in operation and one in construction. So this is a clear example, in my opinion, of resource optimization, something very important today, at least in our Enel Group. Then, right now we are in process of purchasing 2 more units. One we will install in a in another dismantling coal power plant in the north of Spain called As Pontes, and the other one we want to start the installation in December this year for another solar power plant, a power plant in operation, right? So in conclusion, we as Enel Group believe that these kind of projects are a very significant step toward our mission to provide, let me say, more efficient and sustainable service to all our customers. Now Samuel will explain a little bit, well, not a little bit, in a very detailed way, our experience with this Dock 2. So Samuel, go ahead.
Okay, thank you, Paco, for this introduction and talk about our company and our project with the timeline. Okay, let's start in detail with all the project. Where we did the project. As Paco said, we were exploring use cases in two scenarios. The first one was the Teruel thermal power plant, and the second one, the CDH 5 solar park. And here you can see a picture of the area where we installed the dock. As you can see, it's very easy to install. We prepared this area with the gravel. We made this concrete slab, put the fence and the gate, so the pole with here the security camera, and then supply with 220 volts this white box to supply the Dock 2. Then supply with energy the router that we have here into the box with the RG45 cable to supply internet to the dock, and the other supply goes to the camera, the security camera that's work with Wi-Fi. And this is the installation. And finally the connection, the ground connection to have a very safety electrical installation here. So as you guys see, it's very easy to make that. Well, let's talk about the use cases in the thermal power plant. What are the main needs we found? Of course, the first one is the safety of the employees, a fundamental pillar of the company. The fast decision support, then the real-time visualization from the sky to help make decision quickly. Surveillance of the area, and finally the immediate response to adverse situation. And now we are going to go deeper into all these use cases. Well, first one, site digitalization. I think that this is the step zero of this kind of demolition projects. It's necessary to digitalize the terrain and the structure in order to have a real updated map for two reasons. The first one, for base your mission planning in these updated maps. And the second one, and very important too, is because the drone use these models for the anti-collision system. And good options to make this digitalization is the Mavic and the Matrix E drone, enterprise drones. You know that these drones are very good for surveying, but of course, you can do that with the RGB camera for the thermal version, but you will get a lower quality data. For the management of dismantling process and with the base map updated, we created several waypoint missions to capture images from the different point of view. The managers from the design and execution department use these images for the internal presentation of all this project and to monitor day by day the progress and have this repository. Well, and here you can see the grid with the progress on different dates and the different point of view of this demolition of the latest boiler of this old thermal power plant. You can see here is a little thumbnails of the picture, but you can see here all the progress in these activities. That was incredible because it was very visual to see how like 10,000 tons of metal was dismantling. And we was monitoring that with a drone. Well, Another way to monitor the works with more details is the 2D model comparison between different dates. This helps a lot to understand the progress of the works in the field and to keep a graphical repository of these works. Again, it's recommended to do this capture for sure with the Matrix Enterprise Dock version because of the camera, but we did this kind of works, these captures with the thermal version of the drone, and we got a good result for this proposal. Next one, the real-time activity monitoring. This use case was useful to monitoring, for example, this oxycutting operation with a thermal camera, and for monitoring high-risk operation, demolishing these big structures, these concrete structures with the large machines. The live stream of the drone in FlyHub 2 allowed us to visualize these activities and share the streaming with the external companies that are working in this construction, in this decommissioning construction. Next one. Another very important use case of real-time visualization was to visualize in details, the details of the structures before the demolition. We share on a big screen in the site meeting room in the live stream with FlyHub 2, and the experts with this streaming discuss and make decisions and on how to process to make this work, this dismantling works. So it was very, very useful. The site manager say thanks to us to improve this kind of activities with this technology and with the live stream. Very, very easy. Another use case, this the detailing inspection based on 3D model. Okay, how we can do that is very easy. First of all, we create the detailed 3D model with Mavic 3 Enterprise. In this case, I mean, we capture the images with the Mavic 3 Enterprise. Then we process that with DJI Terra. With the model in DJI Terra, we upload that model in FlyHub 2 and create our detailed inspection mission based on this 3D model. And then, for sure, execute this flight with the drone dock version. And I want to say that I was surprised how accurate was the drone, because if you compare the theoretical flight, I mean the theoretical flight planning with the FlyHub 2 and the actual flight capture, the framing of the images are very similar, as you can see here in the video. So this use case allow us to have a detailed digital twin of the assets. It helps us to reduce the difficulty in O&M works, O&M activities, inspect areas of interest in detail for sure, make online annotation, for example, in the 3D models, and of course share all this information. And here in this slide, you have some example of this annotation after the inspection in all the images. Next one, information sync. I want to say that in FlyHub 2, you have very accessible the information. Why? Because, for example, the live stream is you can watch this live stream in multi-platform, like phone, tablet, in the controller if you have the controller in B mode, in slave mode, and in the laptop. Annotation share, you saw in some of these videos different example of annotation, and the platform allow us to download or the original photo or download the photo with the annotation printed. So then just you can attach that in an email or something like that. So it's very easy workflow to do that. And finally, the data is easy share, because if you right click in a folder, then select share, appear this pop-up, and you can share the QR code or share the link, like for example, WeTransfer or something like that. Set a password if you want for more security, and finally, if you want, you can select if you want temporary link or permanent link. Okay, we finished with thermal power plant. As in the thermal power plant, we identified different. Sorry, let me say here that we make the installation in the solar power plant. This is the image of this installation, but in this case was different. In the other case, we provide energy, 220 energy for the I mean, without any renewable energy. And what we made here was make the installation. I mean, the dock is automatic at the installation. The power supply is autonomous too, because we made that with the solar panels and some batteries and create the same scenario. I mean, the same area like 49 square meters of this area with the fence, the same gate, the slave, and all the installation was similar, but the difference was that we made that completely autonomous installation. Okay, and about the use cases, as in the thermal power plant, we identified different needs. For the first one, and the most important, is the worker safety. We talk about that in the other use case. The reduce inspection cost, increase the efficiency in the inspection because we have a drone available 24/7 for the planning supervisor, surveillance of the solar plant, and finally, immediate response to adverse events or needs. So let's see the use cases we perform. Okay, let's start. First one, and pretty similar than what we were talking in the other slide about the use cases in the thermal power plant, because we are going to base our missions in the 3D model or orthophoto of our assets. The first step is digitalize this asset with the drone. What we did, take the Mavic 3 Enterprise with these settings and create the flight, just taking capture ortho photography, I mean zenithal photographies. Then with the service that FlyHub2 provide us with the cloud mapping, we upload all these images because Mavic 3 Enterprise is compatible with FlyHub2. Upload all these images in the platform, and with the cloud mapping, we generate this map in 1 hour more or less with 1,000 photos. Then, because what we did it was upload this map and overlay with the base map from Google Maps in the platform, and based on that, we made the flight of this perimeter patrol. How we did that? With a typical waypoint mission, like in Pilot 2 or something like that. Just create all the waypoints. In this case, for the perimeter patrol, what we did was inspect all the status of all the security camera and the fence, and we create all these waypoints with different picture, the capture of different pictures in the areas of interest, and execute this flight. Just take off and make all the flight around the solar plant, capture all the pictures. It's very, very easy to see that and monitor all these activities with the streaming. Then land the drone, and I want to talk about this topic. We are talking all the time that the automatic flights and so on. FlyHub2 and the Dock 2 solution allow us to fly that manually with this flight to mode is the name of this flight. So just with it's like a video game with the keyboard and with the mouse. With the keyboard you move you make the drone movement, and with the mouse you move the gimbal camera. You can change between wide camera, zoom camera, thermal camera, take pictures, video. It's like if you are flying with a remote control. So you have these two possibilities: make the mission automatic missions, or take the drone manually and inspect something that you want to do manually. Then with all these pictures, I mean with automatic mission or these flight to missions, you can analyze that all these images, upload to the FlyHub2 platform, and take some, like we saw before, some annotations and so on. and you can overlap all the photos in the map. And so on. So let's continue with the next use case, solar panel inspection. Maybe this is the main use case in the solar plant for sure. The most important thing, the first one, is the weather conditions. You know, it's very important for that to have a very sunny day to perform this kind of inspection and get good results. And another important thing that I forgot to talk about that, and we will talk about this in the last slide of this webinar about the regulation, I mean. But I want to note here that we made all these tests, all this flight and so on with a visual observer, with a pilot in the field with a B controller. I mean, the drone has the A controller, the master controller, and you can bind your RC controller like any kind of drones, like a B controller. And if this pilot in the field can take the control in any time. So we have this pilot, this visual observer there to manage the risk and monitor all these activities. Okay, well, suppose that we have a very good weather condition, and again, if we don't have that, I don't want to keep repeating all the time that, but for sure, if we are going to base all these mission plans in the 3D model, we have to digitalize that. I recommend that for sure. If you want and you have in the let me say Google Maps the capture of the solar plant, you can try to plan this mission with this map, but you know it's not very precise, not very detailed to make all of that. And here is how we make this mission plan. As you can see, it's very easy. Sorry, it's very easy to do with this first person view of the drone, how the drone will see during the mission, and you make that like a simulator, like a video game based on this 3D model. Because of that, I say that it's important to make this digitalization first. And that's very easy. What we did, and this is very important, in the first waypoint, I mean, we create that with the waypoints mission route. But what we did in the first waypoint was these 3 icons that you can see here. This is different actions. This is the first one that was lock the yaw axis of the drone. The second one was lock the pitch of the camera pitch to take the picture. And the third one, in this case, what we did is fly between 15 and 20 meters above the panel, and we set a time interval with 2 seconds. So we did that in the first waypoint, and then just with the keyboard and the space bar to create new waypoints, just go for the different rows, the different lines of panels, creating all the waypoints to do that. And as I told you, with the detailed inspection based on 3D model, this was very, very precise between the 3D model and this planification. And then when we perform this inspection, then that you can see here in this little video about that. And for sure, you can share the QR code to see the live stream, or monitor that with FlyHub2 to see that it's all correct and are taking well the picture. And with a visual, you can see the different effects and so on. And finally, sure, we perform this fly and get all the data, all this data. I want to say here something that I think is very important. FlyHub2 doesn't have a very advanced analysis tool for this proposal. I mean, for RGB photos or thermal photos, just a visualizer of all of that. So I think that for this manual quick inspection for a small site, for example, is pretty enough with that. Because if, for example, in this case, you see here some defect, I mean, just visually, because you can check the temperature in the picture right now with the version that we have in the market with FlyHub2. But you can select that with some annotation and tag this defect or something like that. Then you can filter in the folder. And if you want, you can overlay on map the position where was captured the photo. So with these tricks, you can see where is the defect. For example, 1, 2, 3, 4, 5 panels. Okay, 1, 2, 3, 4, 5 panels. You can see here. I think this is maybe this is useful for little rooftops or something like that inspection, but not for the cool plants like 50 megawatts or 100 megawatts, something like that. So what we did for us was analyze these images with an external provider here in Spain to validate that this workflow, that how we create these mission plans, how execute that, and the data capture was good to make this inspection with this new drone, and for sure was very good result with all of that. But again, I want to remark that FlyHub2 is not a platform to make an advanced analysis. If you want that, it's better to use a third-party platform to, three-party providers to do all these kind of things. Next one, high voltage power line. Again, I'm repeating all the time the same. Yeah, we need to base all the mission plans in the 3D model. So what we did is capture digitalize the high voltage, these power lines with the Matrix 350 and the L2. And here you have the best. This is the best settings, the better settings to make this data capture. Okay, so we made that and processed that with DJI Terra. Why with DJI Terra? Because the cloud mapping of FlyHub2 just let us to create the 3D mesh. So the point clouds not possible to do that with cloud mapping service in FlyHub2. So we use DJI Terra, process that, and then upload this file to FlyHub2, overlay on map, and okay. With this, create again. It's the same workflow. What we did is create the waypoint mission and taking picture in our point of interest and these different areas and so on. When we finish to prepare all this all this flight, and remember another things. Remember that it's not only useful to use this point cloud, this 3D capture to base our mission planning. Remember that the drone is using this data for the anti-collision system. So it's very important to have this point clouds in this case in the high voltage power line inspection. So yeah, when we finish to prepare the mission flight, what we did, make the first capture. Perform the first flight. We did that. And then with all these picture captures, we use the AI spot check tool that we have in FlyHub2. What this tool does. With this tool, we can readjust, or let me say, reframe our pictures to get better result. To recenter the picture in our point of interest or our area of interest. Let me see here an example. This is the AI spot check. This is the first flight before use this AI spot check, and you can see that this connector of the insulator and so on is down. So then when we readjust this with the AI spot check tool in FlyHub2, and again do the inspection, we got this other picture. You can see it's very recenter. The reframe is very good to make that. So as I said, then the second time we made the flight with this AI tool load in. Doing this edition with this AI spot check tool, make again this flight, and I want to say that this process doesn't need to be done every time. Just doing that in the first operation, this first time that we make the first picture of this power line, and saving this editing, this reframing with the AI spot check, it's not necessary to repeat this action in the future operation. So yeah, just to summarize, create the 3D model to base the mission and to the collision avoidance system of the drone. Then when we finish this mission plan, capture the first time of these images to do this reframing with the AI tool from FlyHub2, and then we can do again the precise inspection to get better images of our assets to inspect. And sure, this AI tool is just to do this reframing, not an AI tool to make any automatic inspection or something like that. I think in the future, take some notes here. I think in the future you have to create some tools to do that automatically. Okay, and finally, sure, we capture all these images and how we can do with the platform. Make, for example, this photo comparison between the different inspection, different dates, and make this annotation that we talk about that, or overlay the map in the 3D overlay. I mean, overlay the photo in the 3D map to know where is the position of this photo, where was captured that photo, and again share all these file, for example, to the technical department of these inspections and so on. Okay, let's finish with this with the substation inspection. To make that, again, the best that we can do is again digitalize that. And what we did, digitalize with the Matrix 350 and the L2. But what happened? I said, but the configure of this mission plan to the data capture with L2. This is the correct configuration, the correct setting to make this kind of captures. But when I processed that with DJI Terra, I saw that the point cloud was little poor and without density. So in this case, in this scenario, we had two ways. The first way was, okay, we can repeat that with better settings to do that, or let's try to use the traditional photogrammetry to get this point cloud by photogrammetry and create the 3D model. And let's try to do that with a drone version, the thermal version, that's not prepared for this kind of work. So we perform this flight with the typical 5-direction flight of the substation with just 40 meters and 1.5 GSD. We took like 750 photos, and again, why we don't did that with the FlyHub 2 cloud mapping, because just the output of the cloud mapping is the mesh, not the point cloud. So because of that, we use Terra, make that in Terra, and show that we have let me post that. We had a very good dense point cloud to base on that the inspection, the mission plans, and to use that like a collision avoidance of the drone system. So then again, it's the same. Just we create that based on this this point cloud, the different waypoints of the mission to take with the wide camera, the zoom camera, and the thermal camera, all the pictures. Then perform this flight, taking all the captures, pretty similar to the other use cases. Again, for sure, what we did, as I told you, that not only is possible to do that with automatic mission. What we made here was like simulate some fire alarms or something like that in the substation, and take the drone, fly with this flight to mode manually in remote, go to the substation, take some pictures to the insulator, take some thermal picture of the trafo and so on, and see that if this information that we got with that, and send all these pictures to our technical people, if this is a correct way to see if the assets, I mean, all these installations are correct or not. And this is all about the use cases in the technical and the technical possibilities that Dock 2 bringing us. But I want to share with you the difficulty of the implementation. I mean, this legal implementation. I think all of you who knows the regulation know how complicated is the implementation of this technology with 100% automatic flight without pilot in the field supervising the operation. We have seen an important technical feasibility Paco was talking about that at the beginning of the webinar, especially avoiding travel by car of supervisor to the solar plant to take the status, for example, and do it remotely. And for example, monitoring of construction in the thermal power plant demolitions and so on. So yeah, we prepared a project with around 20 dock units to buy and install in different strategic solar park and cluster and the demolition project that Paco told us. But currently we only have one dock because it's not easy to make this implementation at a legal level. As Paco said at the beginning of the webinar, we will install 2 more docks, but let me say that it's hard to fight at the same time with the regulation and the documentation and so on. So for example, if what we see is if we have to continue doing this flight with a pilot in the field, is the same operation that if we do that with a Mavic 3 thermal drone, for example, but Mavic 3 thermal drone is cheaper than this Dock 2 solution. Or if we have to train a pilot in our demolition work to perform this flight, Dock 2 maybe is not the best solution. So I think DJI has to make an effort to bring us this CSIS level, the FTS, parachute, and so on. I'm not very expert in the solar process, but I think this kind of things will be easy to get lower sale number. I mean the risk level for this Dock 2 operation. So please, DJI, focus your effort in that. You have created a very good technical solution, but I think not enough with that. So please work hard with these regulation issues. And I think that a good solution is an only with technical solution. Good solution is something that we can easily, let me say, implement and use in our companies, and yeah, apply with our European regulation, in our case, the European and the Spanish regulation. So please try to help to the customers. And yeah, it's very important to sell a lot of units of this solution, because for sure we believe that is very good solution in terms of technical things, but it's also important to help us to implement all of that. So you are the manufacturer, and I think you are the responsible for all of that. And that's all for me. Thank you for.
Let me pick the mic for
Okay.
a small speech regarding the topics. Yeah, sure. We have a very wide adoption in Chinese and I would say North of America markets, but now we are actually facing some legislation, I would say, challenge, or yeah, in the European markets with Dock 2, those kind of automated solution. Regarding this. I would say the challenges, well, we are doing several efforts already. First, we are trying to make our dock certified as C6 label. We are pushing hard with this process. And second, we are creating more and more documentation for Dock 2 to explain how it works to the regulator to understand the product, how it's being designed, and how it's safely working every day. Yeah, and the third point, we are trying to get in touch with YASA regulator and the local regulator like ISA to do more communication, try to find a easier way for our end user to really adopt the good solution. From technical side, as you just mentioned, yeah, maybe we are meeting your expectation, but from regulation side, we are working on that, and let's try to give some hope to the future, and we are working on that as biggest manufacturer. Also, we have a lot of loyal end user and market participator with us, and together I believe in the future we can make much easier about the regulation problem.
Yeah, I think for the customer point of view, we will say thanks with that if you help us with all of this integration and so on. Yeah,
I'm doing my best.
Thank you. And yeah, that's all. Just say thank you. First of all, thank you, Paco, for let us to do it possible, and for all the team, Ignacio Santalla, our head, and all the team to make it possible. And thank you for sure, DJI and Irving, for this close relationship that we have, and make it possible with this first Dock demo unit here in Europe and so on. Yeah, So we appreciate that a lot. And thank you for have this time with all of you, all the audience, to share our project and all what we did with this solution. Very good technical solution. Yeah, that's all.
Okay. Okay, thanks for the wonderful sharing. I believe we have a lot of, I would say, very dry knowledge to share with our audience. Next, let's try to bring up the questions being asked by the audience. Okay, the first question. Let's talk. Just a moment. Okay, maybe first question starting from this one from Antonio. Could you please provide more details on the 2D and 3D maps generation capabilities? Specifically, how does FlyHub 2 utilize the DJI Terra Cloud Engine for generating 3D model? And how does real-time 3D model generation works? Maybe this question is more from DJI product side. Let me give a quick answer. So we generated the cloud engine from the Terra capability to generate from the photo into 3D model. We put this capability on FlyHub 2, but on the cloud version. And after you capture the data with FlyHub 2, or with, let's say, Dock solution, your photo will be saved in FlyHub 2 server, and on the server automatically generate into 3D model or 2D model. You can also choose how accurate you want to build your 3D model, or you want efficiency. Let's say maybe just 1 from the 10 time accuracy, but you will get a result very fast. So we provide this possibility to our end user and the end user will make the decision by the efficiency and accuracy in a balancing. Okay, next question. Also from Antonio, if anomaly are not visible on the spot, how can real-time detection and automation be handled? Is it possible to automate this process? Well, maybe if I'm understanding right, you mean that during the solar panel thermal inspection, we found some anomaly, and when we want to know the details of the anomaly, it's actually possible to stop the automated mission and make the drone hover there to take more photo or do some further action or support your on-site maintenance worker to enter the site. Also, it's possible to send the thermal photo and RGB photo directly real-time to your team. But currently, we don't have the ability to recognize the anomaly automatically. Yeah, it's as Samuel just mentioned, FlyHub 2 is more of a generate platform. It's not really deep dive in the solar panel analysis or But
if you want,
keep working on that. Yeah,
you can comment if you want about this, the possibility to use the third-party server to send all these images and so on, and use this third-party.
Yeah, thanks for that. Yes, you just remind me. Yes, on FlyHub 2, we provide a URL. It's like a port to generate all the data we created with Dock 2. And with this URL port, you can directly put the data in your platform, in which is our third-party platform. We already achieved this development with the Sitemarks and some other third-party solutions in solar industry. And basically, the workflow will be like when we capture the data will automatically show on their platform and to be analyzed, and later directly give you the reports. Okay. And the next question: when is the AI spot check performant? Before or after the mission? How much does it take to have accurate information? Well, maybe Samuel, you will give more explaining for this. Before the mission.
Yeah, before the. I mean, to use this AI spot check tool, it's necessary to have the first pictures, because with this first picture, the AI tool works to reframe the photo. So just create this first one, take this first picture of your structure, use the AI spot check, and then make this detailed and precise mission fly with this tool activated, with this tool enabled.
Yeah.
And it doesn't take a lot of time. Of course, it depends of the dimension of your mission, but it's very easy just recenter all of that. And just take graphically with the mouse the square and just move to the different areas of your picture, and that's easy.
Also, from DJI side, we are seeking the solution, a better solution for end user. Maybe in the future we're gonna provide something easier to even simplify the workflow. Okay. Okay. Next one. Are there any other issues you believe having hindered the overall implementation and application process? I think the problem is about implementation, installation, and the application process. Yeah, I think the regulation currently is one of our biggest headache to adopt Dock 2. Besides that, maybe some integration with another third party could requires a lot of your bandwidth to discuss with different party to understand their technology, understand how it works, and put them together. This could be challenging. Could be challenge. Yeah, Samuel, how do you think? There's another question like, what is the biggest difficulty to implement Dock 2 in your?
Yeah, the biggest difficulty is about the regulation, as you say. I mean, about this physical installation is pretty easy to do that, and then let me say this software deployment is very easy too. It's just connect the RC controller to the Dock 2 and just read the instruction in the screen of the RC controller and just put next, configure the internet, and that's all. Open your bind your Dock 2 into your FlyHub 2 project, in your FlyHub 2 organization, and it's pretty easy. Yeah, the first time I commented the first time was a little difficult because the user manual that Irving, that DJI provide me, was in Chinese, so for me it was a little difficult to do that the first time. But no, I'm joking. Yeah, it's easy to make that, and not necessary if you don't have this huge area to do that. It's not necessary to make this like I told you, like 49.7 per 7 meter. Like 49 meters square with this fence, and so it's not necessary to do that. We make that to make more professional and so on, and make our best in the project. But you can do that with less things in the field.
Okay, thanks for the answering. We are still having actually many questions, but due to the time, we are reaching like 1 hour 10 minutes. It's a long webinar. So maybe later, I will reply all the questions by emails one by one. And my dear audience, and Samuel and Paco, thank you for your participation on the webinar. And I believe today our knowledge being shared is really valuable for DJI side, also to the audience we are having now. And once again, thank you, and also thank you the participants for joining us. And if you have any questions, please also put it in the chat box, and later I will get back from email. So now we will conclude the webinar, and wishing all of you have a really nice day. And that's it. So thank you.
Thank you.
Thank you. You all. Bye bye.
Thank you.